All right, hello IP Statistics. This is section 6.3, binomial and geometric distributions. You're gonna need a graphing calculator today, so have one out, okay? And we'll get busy on the first part. All right, binomial distribution has 4 characteristics. We have to satisfy all 4 of them for a story or problem to be recognized as binomial. First, your outcomes for each trial will be identified or classified as a success or a failure. When you think of the word binomial, it has the word bi out front, which means 2, okay? And that's why we break this down into 2 parts, either, again, a success or a failure. Second item, trials must be independent, which means that one trial has no influence on the outcome for a later trial, okay? And then further, each trial has the same probability P for success, okay? So the probability does not change for success as you work through more and more trials. Finally, there's a set number n trials, okay, within your activity, whatever you're choosing to do. Okay, we'll talk more about that in a second. So let's use the story here. And I'm going to start with a student named Shayla, who's going to be a fabulous basketball player. She may be already one right now, but she'll even be better. And then let's say for a moment that she will be in the WNBA season 2021. And know that her success for making a 3-point shot in basketball is 65%. Let's assume that in the upcoming season, she shoots in her first game 8 baskets. Okay, she attempts 8 shots. Let's let X be the number of 3-point shots that Sheila makes in a game. Okay, let's assume that each shot also is independent. Okay, now before I move on and do some calculations, let's make sure this is binomial. Okay, if I consider the first item, is there a success-failure relationship here? Yes, there is, okay? The success is making a basket versus a failure, which would be missing a basket. There are really no other options. You're either gonna make it or you're gonna miss it. Second item is that your items are independent, okay? When I say items, we're talking about our trials, and a trial in this case is a shot, and that is identified here in a sentence, and so we will use that as our support. Okay, to say that the second rule is satisfied. Your probability P, in this case, which is 0.65, will stay the same. Okay, and since we're assuming that her 65% came through a long series of events of shots during a basketball game from the time that she was a kid till now, we'll assume that that 65% will be consistent and will not change as her trials move forward. Okay. And finally, there's a set number n, meaning there's a set number of shots that she's going to take in this game, and we had define that in this middle sentence where she's going to shoot the ball 8 times. Okay, 3-point shots. So, since this is binomial, what I can do is ask a question like this: assuming that my n is 8, I'll write this off to the left. My n is 8, and that my probability for success is 0.65. What is the probability that amongst those 8 shots, she will make exactly 4? Okay. Now, for myself, and there's going to be a couple of ways to do this, and I'll show you all of them. I'm a picture guy. I like to draw little lines and say, okay, here's my first shot, here's my second, my third, my fourth, my fifth, my sixth, my seventh, my eighth. Okay. And let's assume that she makes 4. I'll put a star next to those 4. 0.65 is the probability for the first, 0.65 for the second, 0.65 to the third, 0.65 to the fourth, and that she misses the remaining 4. And that would be the failure. If the probability is 0.65 to make it, the probability of a failure is 0.35. How did I get that? Well, I'll just take 1 minus 0.65. And that'll tell me the probability of missing. Okay, so P of, this is X complement. Okay, now I want to make this look a little nicer. Let me make this 0.65 to the 4th power, and then 0.35 to the 4th power. And for many, someone will look at that and say, you know what, that looks sufficient, okay, because you've identified 4 shots that were made and 4 shots that were missed, okay? However, there's actually an additional piece to it, okay? And this additional piece is the consideration that Maybe she didn't make the first 4, miss the second. Maybe she, and I'll just draw this above, she made the first, missed the second, made the next 2, missed the next 3, and made the last one. That's another opportunity where she could have, made 4 and missed 4. Okay, and so when I want to consider all the combinations of making 4 and missing 4, what I'm going to do is out front, I'm going to write this big C for choosing, and I'm going to say that she had 8 shots, and she is choosing to make some arrangements of 4, okay, or some order of 4. Always sounds better. Okay, now you can put that in your graphing calculator. If you're not sure how to get to this C, remember you have to hit the 8 first. And then to get to C, it's math. And then on your calculator, go to probability, and then go down to 3. Okay, and that will get you your NCR. Okay, and then you'll plug in the number 4 after that. Okay, if you do all that math, okay, you should get 0.1875. Okay, and you can put that in your calculator. That's sometimes the hardest part out of all of this, is making sure that you punch the right number sequence. So please give that a try, and just don't accept this as an answer. Okay, and make sure that we have some consistency. Okay, all right. Also, just to let you know, sometimes they don't write your 8C4 this way. I'm going to box this. Sometimes 8C4 is written in this manner. Okay, it's just 8 over 4 without like a bar. Okay, almost like a fraction, but with no bar in the middle. And that's another representation. Your book will do that now and then. Okay. Now, if you're more of a mathematician who loves formulas, there's your formula. All right. It's pretty much the same thing that I wrote. It just doesn't have a picture with it. Okay. The difference is that instead of having an X here, I have a Y, but that's still basically the same idea. Your value that you're searching for, okay, information about, is for X equals 4, so I can put a 4 there. And then your N, we said earlier, was 8. So 8C4, or 8 over 4 with a set of parentheses around it. Your P is 0.65. Your K is 4. Your P is still 0.65, so 1 minus that. And again, your N is 8 minus 4, which will be 4. Okay. So not much difference between the two. If you're just formulaic and you want to use that, that's great. I'm one that's a little bit more visual. I want to draw a picture for myself and then create some math around it, and either way is acceptable. Okay. Third way to do this is using, ta-da, graphing calculator. Okay, and we're gonna actually use a new button that we haven't used yet this year, as far as I remember, and that is your second button, and this one called vars, which above it says distribution. Okay, so second distribution, and if you click on that, you're gonna get a screen that looks like this. Okay, and it's actually a little bit more than that. It's a screen that looks like this after you scroll down, and my goal is to scroll down until you get to the A. Okay, and you'll notice that, again, second distribution, which is the vars, you'll get this, scroll down to A. It says Binomial Pdf. Okay, and so I'm going to write that down and choose that as my command. Okay, and you'll get a screen that looks like this. Most of you, if you have a newer calculator. Okay, you'll put your trials in. In this case, there's 8. This is basically your N. Your P is 0.65, and the X is just the X. It's how many, in this case, 3-point baskets that you're hoping to have. Okay, in this case, it's 4. And if you go down and hit paste, enter once, you should get this screen. Okay, it says Binomial Pdf. Some of you will start off with this screen. You won't have the one above it. Okay, I'll put an X to that. You won't have it. You just plug in 8, 0.65, 4. And that's what I'm going to write is showing my work. I'm going to write 8, 0.65, and 4. That is my N, my P, and my X. And notice I'm labeling that above so that my reader knows where I got those numbers. Okay. And if you hit enter, you'll notice that you get the same number that you got answered, that you answered over here, 0.1875. What does that mean? It means that if Shayla is a 65% three-point shooter and she shoots 8 baskets in a game, or 8 attempts in a game, the probability that she makes exactly 4 is 0.1875. Okay. Now I can do the same thing with 0. Okay, and sometimes it's just easier to use the formula or just kind of write it out like this. When it says, when I say write out like this, I'm kind of mentally in my head saying, here's my 8. Okay, and then she's actually missing all of them. She's missing all 8. So of the 65% that she's supposed to get, okay, there's none of those. And the 0.35, which is the representation for probability of a miss, you got all 8 of those. Okay. Now, why do I write it out like this? Because I know that 8 choose 0. Okay. How many ways can you choose 0 out of 8? 0 groups out of 8, or group is, yeah, I guess that's right, is 1. Okay. If you're choosing none from your group of 8, there's just still 8 left over, if that makes sense. And that's just one group. This, anything to the 0 power, is also 1. And then 0.38 to the 5th will give you 0.000225. Okay. And if you want, you can do it this way. You could have written it the way that we did on the graphing calculator. TI-84, I'm writing the instrument that I'm using to help find this answer. Binomial Pdf. And it would, again, we have 8 is my n, 0.65 is my p, and my x is 0. Okay, and you'd find you get the same thing. Okay, the next one says 3 or less. The probability of having or making 3 baskets from the 3-point line or less. Okay, now think about what that means. That means p is equal to, probability of x is equal to 3. Probability of x is equal to 2. Probability of x is equal to 1. And the probability of x is equal to 0. Don't forget that one. That one's often forgotten. Okay. Now, I'll be honest with you. While we found some good ways to do all of these, I don't want to do this 4 times. Okay, it takes a little bit of time, and I just don't have the energy to do it if there's a quicker way. Okay, so here's what I'm going to do. I'm going to use my TI-84 again. Oops. Okay, and I'm going to use a new command. Okay, instead of, and I'll do this in a different color. Using red, I'll use green. Instead of using A, I'm going to use B. Okay, and A and B look the same. The only difference is there's a C here. Okay, and you'll notice up in this new screen here, it says CDF. CDF stands for cumulative. Okay, cumulative. Okay, and I'll just abbreviate that. What does cumulative mean? Well, cumulative means that you're not only looking at some particular number and at some time, but everything with a value below that. Okay, so this is a good example of that. I'm not just looking at the 3, I'm looking at the values also below 3, which include 2 and 1 and 0. And once I find them all, I will take all those answers and add them up. Okay, now this will do it in one nice big shot for me, so I don't have to consider doing a ton of work. So TI-84, Binomial Cdf. Okay, and again, I have 8, I have 0.65, and I have 3. Okay, and if you put it in the next entry, hit enter, you're going to get exactly what you see here. Again, notice it has a C. That part is important. Okay, and then notice the answer, 0.10609. All right, so there's a 10% chance, maybe a little bit higher, 10.6% chance. Okay, that in this particular game, when shooting 8 baskets or 8 basket attempts, Shayla will make 3 or less baskets. Okay. All right, last one says x is greater than 5. Okay, and when you see this inequality, many of you will say, you know what, that's kind of similar to what we did. The only difference is that it's going in the wrong direction. Okay, do we have a third item where it goes the reverse direction for a greater than sign? And the answer is no, there's not. It only goes from a value to items lower than that. Okay, so here's the deal. When you think of x is greater than 5, First of all, that does not include 5 because there's no equal to sign beneath. But that would be the probability that x equals 6, probability that x equals 7, and actually probability of x equals 8. Okay, and I don't want to do all three of those. Okay, so here's what I'm going to do. All right, if I know that there has to be 8 shots, I'm going to write, I don't know if I'm saying the word complement is right, but that could be it. It's basically the reverse of this. Okay, and then writing it in the form of a 1 minus so that I can actually find this value. Okay, so let me do this. This is the same as 1 minus. Now, x is greater than 5 is represented again by 6, 7, and 8. The opposite of 6, 7, and 8, based off your values here, that what x can be, starts at 0. Okay, starts at 0, and it goes to actually 5. Okay, so this is basically the probability of x is less than or equal to 5. Okay, so again, that is like the reverse representation. If it's not greater than 5, then it's less than or equal to 5. If I can find this guy right here, then I can also find the item that I started with, okay, just by subtracting this from 1. Okay, so what I'll do is I'll plug in a binomial CDF for this because it is less than or equal to. And so that'll read binomial CDF. Okay, and the n is 8. Your p is 0.65. And your x is 4, 5. Okay, and so it looks kind of like this. Okay, 1 minus binomial CDF. Okay, and as you work that out, you will get a 0.4278. Okay, so again, a little bit easier way than just doing 3 sets of these on your own. Okay, and sometimes those sets will be bigger. Sometimes instead of having 3 unique items, you're going to have maybe 6 or 10, and it's like, I don't want to do all that. Okay, I don't want to add a bunch of stuff up after doing these algorithms that kind of take a little bit of time to do. All right, so calculator way is certainly the best. If you ever have a greater than sign, okay, and again, we got to be careful with this. If you ever have a greater than sign, then you have to write 1 minus, and then kind of like the reverse of what you see here. If you see x is greater than 5, then you have to say, okay, what's greater than 5? Let me consider the other numbers in this set, 0 through 8, that are not part of this. Okay, and then if you rewrite that in symbols, find your n, your p, and your x, you'll be set. Okay. All right. Hopefully that all makes sense. If not, send me an email. Okay, we'll talk about it more and make sure that it's more clear. Okay. All right. Next part, okay, is actually a very easy part. It has a lot of simple formulas here, but it talks about some items that we've done in the past, okay? And this story up here is still the same, hasn't changed, okay? But I've added a new question. It says, how many 3-point shots would you expect? And notice that it is in bold. Shayla to make if she were to attempt 8 shots, okay? Meaning, how many shots do you believe Shayla will make on average out of 8 attempts, all right? And so as you read each of those sentences, this idea of on average is an important phrasing, okay? Expect is bold, okay? Because really what I'm asking for, this is asking for the expected value, okay? And what is the expected value? Well, that is the same thing as the average, okay? Now, got a super intense formula for you, okay? You're gonna like it, okay? The average, okay, for this x, okay, the expected value for the number of shots you would expect her to make, okay, out of 8 is just n times p, okay? And so your n in this case was 8, your p is 0.65, okay? And you just got to do the basic math. 8 times 0.65 is 5.2, Okay, so again, super easy formula. Okay, and how would you say that? Well, you know what, she would play many, many, many games and only shoot 8 shots, and assuming that her probability for success is 0.65, it's a long answer, the proportion of shots that she would make out of 8 is about 5.2. Okay. All right. Well, the number of shots she would make out of 8 is about 5.2. Actually, it's 5.2 on average. Okay, what is the standard deviation? So again, for whatever mean we have, we should have a standard deviation because sometimes our data will vary about that mean. And here's the formula we use for that. Okay, it's the standard deviation of x equals n times p times 1 minus p, all square rooted. Okay, so let us put that information in. And n again is 8, p is 0.65, and 1 minus p is 1 minus 0.65. Okay, and again, just put in your calculator, see what you get. And I got 1.349. Okay, and what does that mean? Okay, it means on average, okay, the number of points that she has, sorry, the number of baskets she makes out of 8 will vary by 1.34 from the mean. Okay, so if Shayla attempts 8 baskets, which are 3-point shots, okay, if Shayla attempts 8 3-point shots in a game, the number of makes will vary. Okay, and I always like to say on average, that's just my thing. Okay, by 1.349 shots, or makes, sorry, from the mean. There you go. The mean is tough to see. All right, will they ask you to interpret your standard deviation? Not always, but if they did, there you go. Okay. All right, that is binomial distribution. Okay, so again, you'll have to know the 4 rules. Sometimes they'll ask you to check to make sure that your rules are satisfying a certain problem. Okay, and again, I'm going to go back 1 slide. Okay, that is all the math that you'll need. If you'd like using your graphing calculator, you can use it every single time. However, I'm going to box this really big in the beginning. Make sure you show your work if you're going to use your graphing calculator, which again, for me is encouraged. I would think it's a good tool to use, but make sure you show that step before you give me an answer. Okay.